So the main thing is really to factor this. So the top factors to y plus 5 and y plus 5. And the bottom factors to y minus 3 and y plus 3. And then we get y times y plus 3 over y plus 5. Cross out or make ones, whatever you want to say. And I should get y times y plus 5 all over y minus 3. Done. You can multiply out the top, that's fine, you don't have to. So I could have written y squared plus 5y. Either answer is fine. Okay? The second one, let's see, move this over. Again, I'm just going to factor, and it's a divide problem, so I'm not only am I going to factor, I'm going to flip this. And the top factors to 5x plus 2 times 5x minus 2. And then I have an x plus 3 because I flipped the second one. And the bottom is x plus 3 over x minus 3 and 5x minus 2. If I make ones, I've got a 1 there and a 1 there. So my answer is going to be 5x plus 2 over x minus 3. Whew. And then we have this big ugly one down here. So let's see, what are we going to factor out here? So on the top here, I'm just going to write this a little bit. I'm going to factor in a, and I get a squared minus b squared. And, oh, okay. Okay, so that leaves me with a times a plus b times a minus b. I'm just going to factor all the top first. And then I'm going to get 2a plus b times 2a minus b. And then this last one gets flipped. So that's a minus 1. Okay. And then the bottom factors to, let's see, 2a plus b times a plus b. And then I get a minus b times a minus b all over, and then the last one factors to a times a plus 1. Okay. So if we make a whole bunch of ones, I've got an a plus b and a plus b, a minus b and a minus b, 2a plus b, 2a plus b, and that looks like it. So my answer should be 2a minus b times a minus 1 all over a plus, oh, there's an a minus b there. Sorry, didn't see that one. A minus b times 2a minus b. Okay? All right, there we go. Definitely. Okay, so now we're going to add and subtract fractions. And we cannot add or subtract unless it has what? Common denominator, right? And luckily, the first couple do have the common denominator. If it has a common denominator, all I do is add the top, right? It's just like if there's no variables. I'm just going to add the top and then simplify. So the first one becomes, I have a common denominator. So this becomes 10 over 5n, or 2 over n. Yeah, I think that's right. Okay, questions? Not too hard so far? IJ, are you awake? Yeah. Okay. Number 2, still same common denominator. I have a x plus y and an x plus y. It's the same. So I'm just going to add the top. So I've got x plus x is 2x. And negative 3y plus 5y is 2y all over x plus y. Now I can factor the top. So I'm going to factor the top, right? So the top factors to 2 times x plus y all over x plus y. And I can make 1 now, so those go away. So my answer is 2. That's it. So if I can factor, after I add, if I can factor, I can't. I do. Doesn't happen very often. You can't normally factor normally. Sometimes you can. Okay? And then the last one I'm going to do before I let you guys do some, is a subtraction problem. Again, my denominator's the same, luckily. So this one should be fairly easy. So I have 5a minus 6a, which should be negative a. And I have negative 4 minus a negative 11. Let's see, what's negative 4 minus negative 11? Isn't 7? Yeah, 7. Plus 7 all over a squared minus 6a minus 7. So I'm going to factor this just because I think I can. If I factor a negative 1 out of the top, I get a minus 7. And the bottom factors to negative 7 plus 1. Yep, there we go. So those go away. And I'm going to get, for an answer, negative 1 over a plus 1. Okay? Questions? All right, let's have you guys do it. There's 4 problems right there. Just add the top, right? So on this one I get, let's see, 6a minus 9b all over 30a cubed. And I can factor what can I factor out of the top? A 3. So a minus 9b over 30a cubed. So that leaves me with that should not be a 9. I am so sorry. It should be a 6b. Oh, it should be a 3b. I don't know why I said 6. Wow. Okay. A minus 3b all over 10a cubed. Phew. And, of course, 3 goes into 6 2 times. I am just factoring super badly today. Let me fix this again. 2a minus 3b. There we go. Okay. I think that's right. Second problem, subtract. So x minus x is 0. Negative 6y minus 2y is negative 4y all over 10y squared x. And so I can simplify this to negative 2 over 5yx. Questions? Everyone okay?
Would it be negative 2y?
No, because there's a y on the top and the y squared on the bottom. So I took this y away and one of the y's on the bottom away. Okay, good question. This one's an add, and I get 2a minus 10b all over 10a squared b. Factor a 2 out. Let me see if I can do this one correct this time. So I get a minus 5b all over 10a squared b. So I'm going to get a minus 5b all over 5a squared b. Wow. Okay. And then the last one is v minus v is 0. And negative 4 minus a negative 5 is 1 all over 6v cubed plus 18v squared. Done. Can't do anything with that. Questions? Awesome sauce. Okay. So next, I just want to find the least common multiple of each pair of polynomials. Basically, I want to find the smallest number that they both go into, not the smallest number that goes into both of them. Do you understand the difference between that? Mm-hmm. So I want to find the smallest number that they both go into. So what's the smallest number that both 5y and 8y cubed go into? What's the smallest number? Let's start with the number. What's the smallest number that 5 and 8 go into? 40. Great. Okay. And what's the smallest amount of y's that both y and y cubed go into? So I have 1 y and I have 3 y's. What's the smallest number of y's that the y will go into? 3 y's. Y cubed. Right? Okay. So y cubed. They both have to go into it. So 40y cubed. And that's it. That's what we're doing. Okay? So let's see, where's the next set? Oh, let's make it a little harder. Okay, awesome. So I have this 2 sets of quadratics here. And what I'm going to do first for these is I'm going to factor them because it makes it a little easier to find out what I need to know, I guess. Be an easier way to say it. So I'm going to factor this. This first one factors to x minus 3 times x plus 3. Wow, sorry. And the second one factors to, what does the second one factor to? X minus 3 and x minus 3. So now when I'm doing it this way, I have a little bit different thought process than the first one, because the first one's just a number, right? It's pretty easy to find out what they both go into. This one, so I guess I should start with saying this. Right now, what we're trying to do is basically we're trying to find a common denominator, right? So that's what I'm thinking. What's going to be my common denominator? So when I'm looking at with 2 sets of binomials, I'm going to say on the first one, I need everything that's in the first one. I need an x minus 3 and an x plus 3. I need everything that's in there in my common denominator, okay? So I know right now I have an x minus 3 and an x plus 3. And then I'm going to look at the second set, and I'm going to say, what's in there that's not that I don't already have? So what's in this set here that I don't already have here? Anybody? What's in that second set, that x minus 3 times x minus 3, that I don't have in the x minus 3 times x plus 3? Hunter looks at the board, and then he looks at you. He looks at the board, and he looks at you.
I have no idea. Mine about 2:30.
So what's in the second set that's not in the first set?
A second x minus 3.
A second x minus 3, exactly. Yeah, that's exactly right. There's another second x minus 3. Remember, I have to have something that everything goes into. So what does this go into? Well, it goes into the first half. And what does this go into? Well, it goes into the, let me undo that. It goes into this one and this one. So it has something that both of them go into. So it has to have all the pieces in there. Does that make sense? Okay. So now it's your guys' turn. You've got 3 problems. I'm not going to give. For number A, our common denominator is 120. And then how I decide on the variables, because that's usually people have the hardest part with, I just find the highest variable, and that's it. Right? So I put t to the 4th, u to the 6th, and v squared. That makes it a little easier with variables. It's just whatever the highest one is, because they all have to go into it, so you just choose the highest one. Okay? So on b, it would be a, b to the 6th, c to the 5th. Done. Okay. And then number C, a little trickier, right? So I'm going to factor both of them first. So I'm going to factor a 4 out and get x minus 4. And then factor 6 out and get x squared minus 4x plus 4. And then I can factor again, so I get x minus 2 and x plus 2. And then I get 6 times x minus 2 times x minus 2. So my common denominator, 4 and 6 go into 12. And then on this one, I'm going to need x minus 2 times x plus 2. And then what do I need to add from the second bunch? What do I need from this bunch to make a common denominator? Another x minus 2. Perfect. Another x minus 2. There you go. Done. Okay? And so basically that's how we find our common denominators. That's what we're going to do next, because now we're going to combine this with adding our fractions together. I know, we're going to combine things together. I know. We're going to start simple first. So what's my common denominator between 15x squared and 5x? What's the smallest number that both 15 and 5 go into?
30.
Okay, there's a smaller number. 15, thank you. Okay, so 15 and x squared and x, again, I'm going to use that just thought process. I'm going to take the biggest variable, right? So it's going to be x squared. Okay, is there any questions? So now I'm going to ask myself, what do I multiply this number by to get this one? What do I multiply 15x squared by to get 15x squared? 1. So I'm going to multiply both the top and the bottom by 1. I should have written that a different way. So sorry. Let me fix this. One time. So I'm going to... And it's a fraction. I'm making a fraction. 1 over 1 is 1, right? Are we okay with that? Okay. What do I multiply this fraction by? What do I multiply 5x by to get 15x squared? 3x. So I'm going to multiply this by both the top and the bottom by 3x. And 3x divided by 3x is 1, right? So I didn't change the value of it. I just changed what it looked like. Does that make sense? So 1 times 2 is 2. Plus 3 times 3x is 9x. So my answer is going to be 9x plus 2 all over 15x squared. And there's nothing to simplify. Yeah, that's right. Did I do that right? Okay. Please let me know if I mess up. Okay, so let's go to the next one. Same thing. We started out easy. So what's my common denominator between 2x and 2xy? I'm just going to write it down here. 2xy, very good. Okay, so what do I multiply the first denominator by to get my common denominator? Y. So I'm going to multiply by y over y. What do I multiply my second denominator by to get my common denominator? 1. And multiply by 1 over 1. So 2y times y is 2y squared. Minus 5 times 1 is 5. And I can't simplify, so I'm done. Right? Questions? Once we get to unlike denominators, there's usually not a lot of simplifying after we add stuff together.
I do like that.
Right. So because, especially if you do the least common multiple denominator, if you do a bigger one, there will be some simplifying to do. But that's why we want the smallest number. Okay? And I said usually, sometimes there is some that you can simplify. But, so just be aware of the fact that sometimes you can simplify that. Okay, so let's go ahead and do this. So if I factor this denominator, I get 2 times x minus 2. And so my common denominator is going to be 2 times x minus 2. So this first denominator, I need to multiply, it's missing a 2, so I'm going to multiply by 2. And the second one, I'm just going to multiply by 1. So I get 2x plus 2 minus x plus 1, because I distributed the negative through, just so you guys know what I did. And so I'm going to get x plus 3 over 2 times x minus 2. Done. Yes, no, maybe so? Okay. And then on the last one, common denominator is going to be 5n squared. Multiply this one by n squared over n squared, and this one by 1 over 1. And I get 3mn squared plus 5. Done. That's it. Okay, so let's go to the next two sets. Next set. So my common denominator on number 1 here is x plus 1. So I'm going to multiply the top by x plus 1 and the bottom by x plus 1. And then the second set, I'm going to multiply by 1 over 1. And yes, there is a bottom. Oh, you forgot. Yeah, yes, please answer in chat if you can, so that way I know that you're here and paying attention. Thank you. 4 is a fraction. By putting a 1 under it, I can turn a whole number into a fraction, right? So as long as I have a whole number, I just put a 1 underneath it, it becomes a fraction, and then I'm just doing the same thing. So now I have 4 times x is 4x, and 4 times 1 is 4, and then this is a plus sign, so I have plus x minus 3. So what do I get? What do I get? 5x plus 1 over x plus 1, and I can't simplify that. Okay, beautiful. Okay. Oh, okay, great. So next one, let's see, I have a 3a times a minus 3. Bless you.
Bless you.
That's ugly. Okay. So I think my common denominator is going to be 6a times a minus 3. Eesh. Okay, on the first denominator, what do I need? Well, I need a 3a squared minus 9a. I'm just multiplying it back together on this one. And on this denominator, I need a 2. Is that correct? That is correct. Okay, I need a 2. Okay, if I distribute here, 5a times 3a squared is 15a cubed. And 5a times negative 9a, yeah, negative 9, negative 45a squared minus 2a plus 6. Believe it or not, I actually think I can factor this. I know. So I think I can. I don't know for sure, but I'm going to try.
This kind of works as hi.
Hi.
He says he misses you.
Yeah, well, why have they not?
I'm going to group those.
Did the boom out there break down?
I have no clue, honey. I know. I think I can factor a 15a squared out of the top, and I'm going to get a minus 3. And then I'm going to factor a negative 2 out of the second one and get a minus 3. And then I have a 6a times a minus 3. So all my a minus 3's go away, right? Because I have one in each term. So I should get 15a squared minus 2 all over 6a. Beautiful. Oh, Malachi. I think that's right. That was really ugly, but that works. Okay. All right, your turn, A and B. So my common denominator for the A would be 5 times 2v minus 1. And so this, for the first one, I need to add a 5 to it. And for the second one, I need to add a 2v minus 1 for 2v minus 1. So I'm going to distribute. So I get 5v minus 15. And then I'm going to distribute plus 12v minus 6. So if I add my like terms together, I get 17v minus 21 all over 5 times 2v minus 1. Parenthesis. Okay? So for number b, my common denominator is going to be x minus 4 times 3x minus 5. So for the first one, I'm going to multiply by 3x minus 5 over 3x minus 5. And x minus 4 over x minus 4. So distribute, and I get, what do I get? 15v minus 25. And this is a negative 3 I'm distributing, so I'm going to get a negative 3x plus 12. So that should be 12x minus 13 all over x minus 4 times 3x minus 5. Done. Okay? Nice job. Okay, so I think a few more problems to do. Okay, not too many. How are we doing on time? Okay, we're doing okay. So now we get a little harder, but this is the hardest because now I'm going to have to factor the denominators. So on the first one, my first denominator factors to x plus y times x minus y. Okay, so my common denominator for this problem is going to be x plus y times x minus y. So I need everything in my first denominator, and I already have an x minus y, so I'm good. So what do I need to multiply the first one by? 1 over 1. And what do I need to multiply the second one by? Well, this needs an x plus y. So x plus y. So I get 6xy minus x squared plus xy plus xy plus y squared. I just distributed, right? Okay. And so I'm going to get negative x squared minus 2xy. So plus 4xy minus y squared all over x plus y times x minus y. And there's no way that the top factors, so I'm done. Because I can't take 2 1s and make a 4. Right? There's no way. Right? It's 1y squared and 1x squared, and it needs to add to be 4. There's no way. Excuse me. Woo! Thank you. Okay. So on the second one, we're going to factor both of them. Oh, okay. All right. Factor both of them. Great. So this factors to x plus 5 times x plus 6. Is that right? Yeah. And this one factors to x plus 5 times x plus 4. So what's my common denominator? Well, I need everything in the first one. And I don't know if I'm going to need more space, so I'm going to write it here. So I need x plus 5 times x plus 6. So what's in the second denominator that I need in my common denominator? Anybody? What's in my second denominator that I need in my common denominator? The x plus 4. Good. Okay. So this one needs an x plus 4. And this one needs a x plus 6. So now I'm going to distribute. So I get x squared plus 4x. And I'm distributing a negative 5. So minus 5x minus 30. Whew. So I'm going to get x squared minus x minus 30 all over x plus 5 times x plus 6 times x plus 4. And actually, Hunter, I think the top factors this time. So sorry. So I think this factors to x minus 6 and x plus 5. So x plus 5, x plus 6, and x plus 4. So the plus 5s go away. So my answer is x minus 6 all over x plus 6, x plus 4. Done. So sometimes they can get complicated.
I don't like when they get complicated.
But it wasn't that complicated.
It was so complex.
It was complex.
My brain is broken.
Oh, it's just because it's early in the morning, honey. How are we doing on time? 9:06. Okay. We have 12 minutes. So since we have 12 minutes, I'm just going to do all of them. Is that okay with you guys? Instead of giving you guys time to work on your own. I want to give you time to see these. So this one factors to x minus 2 times x plus 2. So my common denominator is going to be x minus 2 times x plus 2. And now I have 3 fractions. Is that okay? Yeah, I still do the same thing. I want to find a common denominator for all 3 of them, right? So my common denominator is, I've got the x plus 2, the x minus 2, and then it has both of them. So this one needs the x minus 2. And this one needs the x plus 2. And this one needs nothing, so I'm just going to multiply by 1. So in this case, I distribute everything, right? So I've got negative 2x plus 4 plus 5x plus 10 plus x plus 3. Ooh. Okay, so what is this? 5x, 6x, 4x, 14, 15, 16, 7, plus 17. And that's it. Oh, sorry, you guys. Excuse me. Okay. I want to give you the